Hi everyone, we're on 3-3 today, slopes of lines. The next 2 days will be more of a algebra concept that you've had before, but a line is a geometric shape. It's a straight figure made up of points, so it's helpful to talk about it in geometry as well as we go forward. So you've had this before, but slope is rise over run. There's a formula for it. It's the change in y over the change in x. So you subtract the y coordinates, put that in the numerator, and you subtract the x coordinates and you put that in the denominator. So those are the formulas. Oftentimes you hear of slope as being called a rate of change. That's another um, term that we're going to define a little bit more later. One thing I want to just review, if a line goes up and to the right, that means the slope, which is oftentimes abbreviated as m, the slope is a positive number. If the line goes down and to the right, the m is going to be a negative number. Okay, so that's a review concept that I'm sure you know, but I want to cover that here before we go forward as well. So now that we know the formula for slope, let's find the slope of this line. When it's on a graph, it really is quite simple. You could just count simply by going from one point to the next by saying it's a rise over run. So it's a rise of 1, 2, 3, 4, and a run of 1, 2, 3, 4, 5, 6. So it's a rise of 4 and a run of 6. So for 6, this slope is 2/3. But it's helpful to use the slope formula because sometimes you aren't given a graph. So let's use the slope formula as well. The slope is y2 minus y1 in the numerator. So you're going to subtract the y's. 3 subtract a negative 1. 3 minus a negative 1. That goes in the numerator. Divided by x2 minus x1. X is 2 subtract a negative 4. So 2 minus a minus 4 goes in the denominator. So our slope then is 3 plus 1 is 4. 2 minus a minus 4 is 2 plus 4, and 2 plus 4 is 6. So as you can see, we get the exact same answer whether you just count when it's on a graph or when you use the slope formula. So slope is 2/3. Why don't you guys pause the video, please, and try this one on your own. After you tried it, you should have done this. The slope is y2 minus y1 over x2 minus x1. Notice how it's the same difference. Some of you might have done y2 of 7 minus y1. You might have done this one minus this one divided by x2 minus x1. You might have done a negative 3, subtract 5. They're both going to give you the same result. A negative 2 minus 7 is a negative 9. And 5 minus a minus 3 is 5 plus 3, which is 8. So my m is a rise of a negative 9 and over 8. So a negative 9/8. We'd get the same thing if you changed, if this is x1, y1, x2, y2, or if this was x1, y1, and this one was x2, y2, you'll get the exact same answer. 7 minus a minus is 7 plus 2, which is 9. A negative 3 minus 5 is a negative 8. And 9 divided by a negative 8 is the same thing as a negative 9 divided by a positive 8. So the answers are indeed the same. Now we're going to get on to a new term, and it's a rate of change, but it is another way of saying slope. Rate of change is how something changes over time, or sometimes we call it how a quantity changes over time. Some books will say quantity. How a quantity changes over time. So examples might be something like this. Speed is a rate of change. It's how something changes over time. And notice how it's kind of like slope. If we think about 50 miles per hour or something like that. We go 50 miles per 1 hour. So it's a change in y over a change in x. That's the same thing as you can go 100 miles in 2 hours. Or you can go 200 miles in 4 hours. Okay? Those are all changes of y over changes in x. rent $800 a month is how something changes over time. If we pay $800 for the month of January, for January and February, it's $1,600 in 2 months. And then we can keep on going from there. It is a fraction. It's a rate of change. It's a slope. So here we have a word problem here. For one manufacturer of camping equipment between 1990 and 2000, annual sales have increased by 7.4 million per year. So this is kind of like the slope. The rate of change is 7.4 million per year, so over 1 year. So if this were to continue, let's see here, in 2000 the total sales were 85.9 million. If the sales increase at the same rate, if it continues to increase by 7.4 million per year, what would the total sales be in 2010? If we almost kind of think about a graph on this one, in the year 1990, in the year 2000, for each year of increase, it's 7.4 million. So it increases 7.4. And then for one more additional year, 7.4 million. And then for one more year, 7.4, 7.4, 7.4. And it's this rate of change, whereas X increases, Y increases. So that's what we're kind of looking at here. So now let's answer the question. In 2000, the total sales were 85.9 million. So if this was where it was in 2000, 10 years later, what would it be? Well, if it increases 7.4 million every year, if we take 7.4 million times 10, that's how much it would increase in 10 years. So that would be 74 million. So in 10 years, it will increase 74 million, and we would then add that to the 85.9 million that it was in 2000. So we're going to add 74 plus 85.9 million. We add those two together, and we get 159.9 million. All right. We're getting on to our last concept in this video, and that's parallel and perpendicular lines. Let's review quickly what perpendicular lines mean. Perpendicular lines are lines that intersect at 90-degree angles. So we might have a line that looks like this and a line that looks like this. This angle right here is 90 degrees. So the slopes, let's say this slope of this blue line is a rise of 1 and a run of 4, we'll say, for example. So if the slope is 1/4, now this green line, its slope is going to be the opposite reciprocal. So it's going to go down 4 over 1, for example, a negative 4 over 1. So the opposite reciprocal slope is what determines perpendicular lines. So we flip-flop the fraction and we change the sign on the fraction for perpendicular lines. For their slopes are opposite reciprocals. For parallel lines never ever ever touch. So if these two lines never ever ever touch, I'm going to try to draw this one a little bit better. If this slope is a rise of 2, run of 5, for example, then this slope is also a rise of 2, run of 5. They're always going to stay the same distance away from each other, so they're always going to have the exact same slope. Rise of 2, run of 5. Rise of 2, run of 5. Rise of 2, run of 5. It goes that way for ever and eternity, as long as the line goes. So they're going to have the exact same slope, or the slopes are equal to each other. So with that being said, we can now ask ourselves the question: line P and line N, are they parallel? Are they perpendicular? Or are they neither? Well, we could simply find the slopes of both lines and compare them. So here is the slope. Here's M for line P. It's going to be y2 minus y1 over x2 minus x1. So negative 3 minus 2 is a negative 5. 6 minus 4 is a positive 2. So my M is a negative 5/2 for line P. Now line N, I can already start saying right now, if I get a slope of a negative 5 halves, it's parallel. If I get a slope of a positive 2/5, it's perpendicular. If I get any other number, it's going to be neither. So here we go. Let's find the slope. Here's my M for line N. It's going to be y2 minus y1, 10 subtract 5, over x2 minus x1, a negative 3 subtract a negative 1. 10 minus 5 is 5. A negative 3 minus a minus is a negative 3 plus 1, which is a negative 2. And oftentimes, just for the sake of consistency and because it's easier, we often deal with negative numbers in the numerator. So 5 over a negative 2 is the same thing as a negative 5 over a positive 2. So line P and line N. Are these two the same? Are they opposite reciprocals, or are they neither? They are the same. So if slopes are the same, those two lines are parallel. Last one for the day. Graph the line that passes through 4, 3 and is perpendicular to line AB. Let's first graph line AB. So let's go left 3 and up 4. There is point A, and point B is right 1, up 9. Alright, so there is line AB. We can consider it going on forever. So we want to graph a line that passes through 4, 3 and is perpendicular. So if it's 4, 3, right, 1, 2, 3, 4, up 1, 2, 3. So here is that point 4, 3, and I want a perpendicular line. So right now I want you to picture, you don't have to draw this, but I want you to picture kind of a line going like this that forms a 90-degree angle with the red line AB. So the way to do that is to find the slope of AB and then graph the perpendicular slope. So here is the slope of line AB. The slope is 9 minus 4 over 1 subtract a negative 3. The slope is a positive 5 over a positive 4. To go from point A to point B, it's a rise of 5 and a run of 4. So that means the perpendicular slope is going to be the opposite reciprocal. So the perpendicular M, remember that upside down T means perpendicular, the perpendicular slope is a negative 4/5. So change the sign and flip-flop the fraction. So from this point of 4, 3, I'm going to go down 1, 2, 3, 4 and over 1, 2, 3, 4, 5 and put a point. I'm going to do that as I go left 5 up 4, left 1, 2, 3, 4, 5 up 1, 2, 3, 4. Left 1, 2, 3, 4, 5 up 1, 2, 3, 4. This, my friends, is the perpendicular line to line AB. Let me know if you have any questions about slope, rate of change, or parallel and perpendicular lines when you get to class tomorrow.